Mm, So in this question, it is asking that what are half angle and double angle identities? Okay, I'll just read the definition first. I'll just write it. Half angle and double angle identities. Now the formula obtained by considering the half of the trigonometric functions as half of the original angles is named as half angle formula. Okay. Depending on quadrant in which the half angle lies, consider cos 2x equal to 1 minus 2 sine square x. Let x equal to x over 2. Then the half angle formula for sine function is obtained as um, they have just manipulated. Okay, half angle for cosine, and here they have calculated half angle for tangent function, and double angle formulas, double angle cosine. First, I'll start with double angle because they have obviously given a very lengthy solution here. So first I'll start with the double angle because like people are more familiar with double angle identities. So double angle. So it double angle identities are basically, so for example, if you have let's say sine of 30 degree, cosine of 30 degree and tangent of 30 degree, and you want to calculate the trigonometric ratios for 60 degree, which is double the angle which you or whose trigonometric ratios you already know. So in that case, we use double angle identities to find the trigonometric ratios for the like double the angle. So it is like uh, from the name itself, it clearly states that if we know the if we know the half of the angle, or if we know the trigonometric ratios for half of the angle, we can calculate its double, or we can just calculate like its double the trigonometric ratio for its double angle. So like there is also not pretty much to explain. So sine, let's say 2x. So again, if I have the trigonometric ratios for sine x, cosine x, and tangent x, then I can write sine of 2x will be sine square x 2 times, sorry, not sine square x, it will be sine x only, 2 times sine x times cosine x. For cosine, we have cosine square x minus sine square x, or 1 minus 2 cosine square x, or for cosine we have three formulas. I don't know why, but cosine gets a special kind of treatment, minus 1. For tangent we have tangent 2x is 2 times of tangent x over 1 minus tangent square of x. Now for obviously we have derivations for sine 2x, cosine 2x, and tangent 2x, which you can clearly see in this solution also. I can also go with this. Let's do the derivation of sine 2x. Then I will do the derivation of cosine for the first one, and then tangent. Okay. So the formula for sine a plus b is sin A cos B plus cos A sin B. So I'll just put A equal to x and B equal to x. That will become sine 2x. So this will be sine of 2x will be sin x cosine x plus cosine x sin x. I'll just write this a equal to x and b equal to x. Now again I can say that this is nothing but 2 sine x cosine x. Similarly we'll go with the cosine. So cosine of a plus b is cosine a minus sine a and then sine b. Again I'll put a and b as x. This will become 2x and this will become cosine x, again cosine x minus sine x and again sine x. So this will again be can be written as cosine 2x is these two terms can be multiplied and it will be cosine square x minus sine square x. And then you can use the property like sine square plus cosine square equal to 1. You can solve it for cosine square, then you can solve it for sine square and put the value of those terms here, so you will get the other two formulas. Tangent of a plus b is tangent a plus tangent b over 1 minus tangent a tangent b. Again I'll put a and b as x, so this will become plus tangent x over 1 minus tangent x times tangent of x. So this will again can be written as tangent square x over 1 minus 2 tangent x, 2 tangent x over tangent square x. Now we'll go for half angle identities. So in the case of half angle, so earlier I was talking about if you knew the trigonometric ratios for 30, then you can calculate for 60. You can do the opposite also. So if you know the trigonometric ratios for 60, you can calculate it for 30. Like these kind of practices we do to find the trigonometric ratios of, let's say, 15 degree and then 7.5 degrees, if we do not have a calculator. But like in engineering applications we always use calculator because we don't have the um, time to waste on calculations like this. So I already told you the formula for sine 2x, which is 2 sine x cosine x. What we'll be doing is that we'll be putting x equal to x over 2. So this will become sine 2 times x over 2 to sine x over 2 cosine x over 2. And this and this can get cancelled, and this will become sine x over 2 is 2 sine x over 2 sine x, this will become sine x and cosine x over 2. They haven't done this half angle formula for sine function. Okay, so basically they okay. I will be not using this one, although we can definitely calculate, but here we have two sine, we have sine and cosine also. We'll use the cosine 2x equal to 1 minus 2 sine square x. Yeah, so here we have only sine and one cosine. Yeah, so this will be easier. We'll put x equal to x over 2, that will become cosine of 2 times x over 2 to 1 minus 2 times sine square x over 2. this and this can get cancelled, and we'll have cosine x equal to 1 minus 2 sine square x over 2. Now we'll be solving this for sine x over 2. So I can take this term here and this one here. So it will become 2 sine square x over 2 equal to 1 minus cosine of x. Again x, let's say x, you have 60 degree and you wanted to calculate for 30, then this will become 60 by 2, which is 30, and then you can just calculate. So we'll be dividing both the sides with 2, and this will become sine square x over 2 is equals to 1 minus cosine x over 2. Now we'll take the square root on both the sides. So finally we'll be ending up with 1 minus cosine x over 2. Similarly, we can do for the cosine. Again, I'll take cosine 2x is nothing but 2 cosine square x minus 1. Then I'll put x equal to x over 2. So this will become cosine of x, and this will become 2 cosine square x over 2 minus 1. And then I'll take 1 on this side, and I'll just flip this term, so I'll just write it like this: x over 2 equal to 1 plus cosine x. Again, I'll divide both the sides with 2. 1 plus cosine of x over 2. I'll take square root on both the sides. So this will become cosine x over 2 is square root of 1 plus cosine x over 2. Again, this is a very lengthy question. Okay, so this was cosine x over 2. Yeah, at last we'll be doing with tangent also. So tangent of 2x was 2 tangent of x over 1 minus tangent square x. In this case, I think we'll be getting a quadratic equation. I'll just cross check this. Okay, so instead of going with this one, we'll write, this was easier, yeah. X over 2 is sine of x over 2 over cosine of x over 2, and we have already calculated sine of x over 2 will be square root of 1 minus cosine x over 2 over cosine x over 2 was 1 plus cosine x over 2. This 2 and 2 can get cancelled, and this will become square root of 1 minus cosine x over 1 plus cosine x. Let's just check this. And now what they have done, okay, so they have rationalized also. We'll do the rationalization. So we'll do the rationalization with 1 minus cosine x over 1 minus cosine x. This will become, in the denominator we'll get 1 minus cosine square x will be sine square x. This will be 1 minus cosine x whole square over sine square x. This is operated on both them. And finally, I guess we'll just This will become 1 minus cosine x over sine x. So I guess finally we have done this one. This was a very lengthy question, seriously. I'll just write correct solution and move ahead. Correct solution. Great work. This was question 6.